So once we've verified our I/O configuration, that we do have it set up properly for 4 to 20 milliamps, go back over that real quick. We need to adjust our program. I've got a couple files that you will download, and then you'll have to modify your program. You can leave, if you've got a program that's controlling the outputs, leave it in there, and then on the next available rung, I want you to add all of this. So you can print out that file. You'll be making that, adding this to your regular file. So you're going to add a couple subroutines. We're going to have some move statements when some inputs come on. We're gonna get our analog outputs working on the MicroLogix. So this is in the main program. It'll be ladder 2. Then you'll create a subroutine. You can do that right here by doing program files. I'm in remote run. I can't do it now. You have to be offline, but you'll hit new, and that'll be how you can add. That's how you will add to it. So that's how I added this one. So these AO1, AO2 are very similar, exact same layout, except this one uses N70, C50, and source 020. So this is going to put values in output to 0. And if we go to output module and open it up and change it to decimal, we can see that the program, as it's running now, this is the value that's going out our analog channel 2 output. And here is our analog channel 2 1. So we're writing this program, it's just randomly, I'm just making up some numbers so we can go do some verification. So we're just going to have, every time the counter goes to 20, it's going to look and see, am I less than 28,000? If it's less than 28,000, it's going to add a value to N70. And if it is greater than or equal to 28,000, it's going to subtract a number. And then eventually, right here, it will move, it'll update that value from N70 and put it in our analog output. So that's that one. Analog 2, like I said, it's pretty much the same program. N71, C51. You got to make sure you get these changed, or you could end up getting a faulted CPU because we want to keep these separate. So I got to be 1419. Let me see what I did here. 1419. We should change these. So let me go back and go to offline. And I'm going to go into analog 2 just so it's been working, but let's make them different. So it's something I just caught. So, all right, so here I used a B3, B39, so that's B3, 15, 14, 13, and 12. Oh, and by the way, since we're here, you may open up your B file, and maybe you don't see all these down here. Well, click Properties. When you go to Properties, Elements. You can change elements. If I change it to 5 and hit Apply, you see it made it 5. Properties. I go to here, put it back to 10, Apply, OK. So you may have to do that with your Bs. And you may also have to do it with your counters. Again, properties, select how many elements, that means how many counters do you want. And you may have to do it with the N7s. If it just shows up, so here I have 1, 2, 3, 4, 5 properties, I got 5. So you may have to go and open those up if you do not have them, if they're already not downloaded, expanded in the MicroLogix controller. So, but we'll write these programs up, and once we do, you'll need to do a verify, and then once you do, save your program. Like I said, add this to your main. Leave your regular program to start adding on in the rungs. Download these 3 documents, PDF files. update your program, and then you can go download it. So I went back into run mode, and we may have to, sometimes it's going to take off. If it doesn't take off, if it looks like it's stuck, it's always off. You just have to go in here, hit toggle bit. But we've got some stuff going. When this happens, it's going to move a high number into there. So it's going to be like the max value. And then over here, we're going to kind of do this. It'll reset it low. So we can go back and monitor this in the output reference. And best thing is go to decimal. And right now you can see the outputs are moving around. So that's the value that you're sending out of the MicroLogix. Maybe we're sending it out to control something, and that's what analog outputs would be. We're sending a signal output to maybe control something that requires a 4 to 20 milliamp signal. Maybe it's a motorized valve. When it's low, maybe it's going to be barely open. When it's high, it's going to be full open. It could be just the opposite. So that's kind of what analogs can do. So get your program updated, verify your analog output values are working, you're not getting a fault, and get it and go from there.